Hello friends, I'm back with another video. Uh, this time it is HTTP and APIs. And last time I got a comment on the video for DNS that somebody wants to understand latency based DNS. So I will start with that first. We'll spend around 4 to 5 minutes over there, and then we can jump into our actual topic of HTTP and APIs. So latency based DNS, what it is exactly, I will explain. Okay, so let's say you are trying to access a url, okay, from your laptop. You're accessing a url https colon slash slash www dot google dot com. As we understood last time, that this laptop will actually connect some to some dns server. This dns server will do some iterative queries to your root servers, then TLD servers, then authoritative servers of google.com, authoritative google.com, and then get the address of the actual google.com server, which will be an IP address like 124.1.1.1. This is a hypothetical IP address. Just for the sake of explanation, I have written it over here. So using this IP address, then this laptop will connect to google.com. So this is how DNS works. This is what I explained last time in a bit of a detail in my last video. Now, what is latency based DNS? Now the world is huge. The internet is huge, correct? And there are so many servers, and Google will not rely only on one server or one IP address, correct, over the internet. It will in fact have servers across regions. Maybe it will have some server in Singapore, some server in India, some server in US, right? So that if one server fails, it can route traffic automatically to other servers, so that there is no downtime. I mean, have you ever heard that Google went down, or when you're trying to access in the browser www.google.com, it is not working, not available, or you get an error saying that page not available? It doesn't happen. It rarely happens. I mean, I haven't seen it. I haven't seen that in my lifetime, at least. So how does that redundancy happen? How is it always available? So that is where the concept of HA comes into picture. That means there are multiple servers. Now, apart from being multiple servers across the region, I mean across multiple regions, uh, there is something called as latency based. So, for example, I will just take another this. So, for example, if you are a client who's sitting in India, and you, okay, this became something else, and you somehow uh, try to connect to google.com. Okay, now google.com DNS servers which are there, okay, they will respond. Ideally, how they will respond is that they know that there are multiple servers across multiple regions, right? Now what they want is that they want to give an answer to this client, this laptop, okay, uh, such an answer that it is able to reach to its URL or its page in the fastest manner. Okay, so for example, what this DNS server can do actually is try to understand that this server is in India, Singapore, and US, right? It will try to understand that how far are these servers, or how fast these servers can be accessible from this laptop. Okay, how it does that is that there are two three mechanisms. What it will check is that, so let's say for example, first is if we take a very simple, start with simple example or simple method, that is called as geolocation based. It is pretty obvious that if this client is in India and there is a server in India which has to process this request, then of course the DNS server, instead of giving the IP address of Singapore or US, it will give the IP address of India server of Google. By the way, just for your understanding, all these servers are hosting the same content, the google.com page. So you need to understand that it is redundancy, it is the same content available in all those servers, and it can be accessible from anywhere over the world, from any place over the world. Okay, so now first is geolocation, but it happens many times, by the way. Although your server is closest or it is located within your region, there is a possibility that it has gone slow and it is responding slow, or maybe the ISP is connecting in between are responding slow. So here comes the part where there are routers in between, right? And these routers can actually give you the uh, routing latency, I would say, in terms of when you're trying to reach from this path to India and we're trying to reach from this path to Singapore, maybe the latency is less. Maybe here you have 200 millisecond, here you have 100. So there is a possibility that even although you are in India, it will give a response or try to give a response to you for connecting to Singapore IP address. So that is based on routing latency. The third part is basically the actual response time. For example, this DNS server can also probe these IP address and try to see how much is the latency directly. Okay, but it will not keep on probing all the time, but whenever that request comes, it will try to probe that how much, whether this server is available or not, or how much latency it is offering. Once it gets that latency, then based on that, it is very much possible that if the US server from India or from Indian DNS server to the US server, the latency is less, it can give you the uh, US IP address in response, and then the laptop will connect to the US IP address. So this concept is called as latency based DNS. Okay, so one is geolocation, one is routing, third is actually probing or probing, yeah, probing the latency and giving the response. Okay, thank you guys. So this was the explanation of DNS server. Okay, let's start with our actual original topic for today. That is HTTP and APIs. Now, what is HTTP? What is APIs? Let us understand that. Uh, okay, I'll start over here itself. So, what is HTTP? HTTP has basically a full form which is Hypertext Transfer Protocol. Okay, hypertext means basically it started all with the HTML language, but now you can have images and JSON as well. So I will just write HTML or JSON or images. Okay, that means these formats or this type of data can be exchanged. I mean, many more, by the way. It's not limited to this. Many more style formats can be exchanged using the HTTP protocol or HTTP uh, system, I should say. Okay, now hypertext comprises of the format. Transfer is that you're transferring data from one place to another. It is basically a client server or front end to back end, a back end to front end, which we have already seen in our past videos. And protocol is basically the language or maybe set of rules which are being used for this transfer. So that is the meaning of HTTP, hypertext transfer protocol, where two systems are actually transferring some data. That data can be in the form of HTML, can be in the form of HTML, can be JSON, can be images, can be many more, right? And that transfer is happening between one system to another system, and there are certain rules or principles to follow, which is your protocol part. Okay, so that is the basic definition of or the meaning of HTTP. Now let's see what HTTP is made of. HTTP has certain methods, but before jumping to that, let me just clarify the basics once again. So whenever you see any URL in your browser, if you go and check properly, it always starts from HTTP or HTTPS. S is for secure, by the way. HTTPS colon slash slash, then maybe www.gmail.com. Okay, so that is where your HTTP comes into picture, and it is part of your URL. Okay, okay. Now moving to your methods, let's see what are HTTP methods. Okay, so let's talk about HTTP methods this time. We in my previous videos we understood that we may have a client, a browser, and a server, and we are using a URL to communicate. While we are doing so, uh, we are uh, using some methods which I want to explain. So those methods will be uh, actions. So basically, whenever the client sends a request to the server, it actually sends a verb. These actions are verbs, okay, along with that request, so that the server understands that what is the expectation from the server. Simple. Okay, so these are specific actions or HTTP verbs or methods which is passed, okay, along with the URL to the server, hitting the URL to the server, and the server understands that what is the request, why this request has come to the server. Simple. Now these requests are simple. One is get. Get means the client is trying to fetch some data from the server. Next is post. That means the client is trying to create a new data on the server. Next is put. That means the client is trying to update some data, existing existing data. And the last, these are popular methods, by the way. Okay, and the last one is delete. That means delete some data. Okay, now there are certain nuances or highlights which you should know. So for example, this fetch is always the default action when you open a URL, for any URL in the browser. The get is the default. Post is something when you are filling up some form. Okay, whenever you fill up some form, a registration form or a online entry form, or maybe if you take a banking example, you are entering the from account to account, IFSC code and other details. That also is a form which you are filling, maybe from a browser or a mobile app, and that will be a post request always. That means you are creating that request. Put is something which you are updating. It's very simple, that there is some record already there in the database on the application server that you are updating. Delete is something which is never allowed normally. Keep that in mind. In fact, in financial institutions or critical institutions, only post is something which is extensively used. Get is only used by default for the initial URL access. So these are some nuances about the HTTP methods, or I should say HTTP actions, which you need to understand. I'll show you how this works in reality by using a Postman or a browser. Okay, so these are HTTP methods. Now moving on, there are status codes. So when I told you there are HTTP methods, whenever you call these methods or call the URL using methods, you will get an initial status code from the server. For example, if you have your client again, server, you sent a get request to the server. Even before server responds to the actual get request, there are certain parameters which it will try to validate. Okay, and it will send a status code, a 3-digit status code, back to the client. Okay, it can be something like 200. Okay, so how it is called is that, how it is named is that, this 200 is the status code, and this is called as the status line. So for example, if you get something like this, 500 internal server error, this part is the status line, this part is the status code. uh, you may get something like 400, if I'm not wrong, this is 400, maybe bad request. That means the server is expecting something and it is getting something else, so it's responding that it's a bad request. Similarly, maybe 401 means unauthorized. Okay, so these are all status codes. You can Google for more. Anything which starts from 2xx is good. 4xx is server giving some uh, business error, we call it as business error, something wrong at the server side. Okay, and 5xx are basically technical errors. I'll not write it over here. I'll write 5xx over here. These are technical errors. That means maybe server not reachable or service is not available, service down. Those are 5xx errors or status codes. So these status codes help you in troubleshooting and figuring out what is happening at the server side. This is important for you to know. This is the concept of status codes, and these precede. That means before you get the actual response, you get these status codes, by the way. So these are not part of your request header body or response header body. Just keep in mind the status line is a separate entity before your this response. It is not a kind of a response header or response body. It comes before that. Okay. Okay, so that was status codes. I think the last part is REST API principle. So first of all, let me explain what is an API. So API by definition is application programming interface. The important part which you need to focus on is interface. That means these API or APIs are actually used for exchange of data. Correct? Request response. Client requests something, you get a response from the server. But who's responding? When you say server is responding, this is the server responding. This server has actually an interface which is responsible for responding. That means if there is a client again and it is trying to connect to the server, it will actually hit this interface. This interface is nothing but a kind of a controller in coding terminology, which actually takes your request and then responds. So this interface is nothing but an API. How it looks is that if you are using a URL, let's say you are using a URL for ABC bank dot bank.in, okay, that URL will help this client to reach to the server. But after reaching the server, which is the exact service or the endpoint which it wants to hit, because this server is a, let's say it's a banking server, okay, to hypothetically it's a banking server and it has a lot of services. For example, it can show you the balance, it can do a fund transfer, it can show you your profile, right? So how do you differentiate between all these? And these all must have some interface, your API interface to respond, right? So these interfaces are actually having something like this slash, let's say, get balance. The if the client actually enters in the URL, and after the URL there is written get balance, then this controller will understand that it is trying to fetch the balance from the database, and accordingly it will connect and respond. It can connect and respond. Okay. Same way, if here after the URL it is written initiate fund transfer, let's say. So this initiate fund transfer, if you have like this URL slash initiate fund transfer, that will again hit a controller and there will be an interface, an API, which will then respond back. It will take the request, probably it can have a from to account details and process it and then give a response that it is a success. Okay, so these are actually called as APIs, or there is one more way to call them is endpoints, because your connection actually ends or hits this endpoint, which then does the processing part. Okay, so I hope I was able to explain API properly. Now uh, maximum uh, APIs used in this world are following a format called as REST, okay, which is your representational state transfer. Now it has certain principles why it is called as REST. Is I'll tell you, REST is nothing but a kind of a contract, by the way, an agreement between two systems. Okay, what it does is, or what it expects, I should say, is that there are 3 to 4 nuances around it. I'll just rub this off. Okay, what it expects is that you should use correct HTTP methods. That is the first principle. Second, you should use proper URLs and endpoints, I should say, which I just explained it to you that these are endpoints. Okay. Third is that whenever you're creating a request, in your request, you should have the entire state. So when I say entire state, if you're creating a fund transfer request, okay, and you are sending from account and to account, okay, in your request, if you miss the to account, if you don't add the to account entry, then what is going to happen? This is going to fail. So that's the reason that the entire state, for example, you may have other entries also, such as customer ID, such as timestamp. So if you're not sending the entire state or all the fields, what is going to happen is that this request between a client and a server will fail. That's the reason your request should have the entire state. Okay. Last point is that it should return data in a standard format. That means return data in standard format. Normally it is always JSON. Okay, it's always JSON. JSON is simple, right? It's just a key value pair. We saw it last time. Key value pair. That means uh, name. I'll write my name. SN. Then age. 22. My age is not 22, by the way. Okay, so here this is a very clean format which you can use, and this is called as JSON, which is used for REST APIs. So if you are following these four principles, you are actually using REST APIs. REST APIs follow these four principles, and this is how the data exchange or the data transfer happens.